All right, hello everyone, guys. Today we're wrapping up chapter. What is it? Chapter 4 we're on. Okay, we're going to be talking about quadratics with imaginary solutions. So this is kind of an extension of yesterday's lesson. We call it a 4.6 part 2. Okay, we're going to use the quadratic formula to solve these, guys. These are parabolas. Maybe let me. I want to cross out number 9. We won't do number 4 here. I should have made it a little more room on the sheet here, but I didn't. Guys, quadratics that have imaginary solutions, we've talked about the graphs of them. Yeah, it's been a while. It was back at the beginning of chapter 4. If we had a parabola where it didn't cross the x-axis, we said at the time it had no real solutions. Okay, and guys, we haven't really talked about why that would be, but if you recall yesterday when doing the quadratic formula, this negative b, it's plus or minus square root of b squared minus 4ac all over 2a, okay? This part here, that's called the discriminant, okay? If the discriminant, if that ended up being a negative, okay, what do we know you can't do? You can't take the square root of a negative number. What we learned here in chapter 4 is the square root of a negative number could be imaginary. Okay, you can use I, which is imaginary. Okay, so these have imaginary solutions. If you plug it into the quadratic formula, we're going to see under our square root it's going to be a negative number. We're going to use the imaginary unit I to simplify it the rest of the way. Okay, so they don't have any real solutions still, but they do have imaginary solutions. Okay, so let's see how this works. Let's do 3 examples here. I think that should give you a good idea of your homework. Okay, your homework's very similar to this. It's got 4 problems on it. So I guess I'm taking it easy here, doing 3. But I think once we do 3 examples, you guys will really have the hang of it. So equal to 0, it's in standard form. We gotta always make sure they're equal to 0. I think I got another example or 2 that does have that, where it's not equal to 0. So this one is A then is 9, B is 3, and C is 7. So again, substituting into that quadratic formula, we got negative B, so negative 3 plus or minus the square root of B squared minus 4AC all over 2 times A. All right, so simplifying this, guys, we've got negative 3 plus or minus square root of 3 squared, that's 9, minus 4 times 9, 36, and then 36 times 7. Whew. Started off with a tough one, guys. Let me pull out my calculator here. I certainly can't do the mental math there. So we've got 4 times 9 times 7. That's negative 252, so minus 252. All over 2 times 9, that's 18, of course. Okay, so we're going to do 9 minus 252. It's going to be at negative 243. We've got x equals negative 3 plus or minus the square root of negative 243 all over 18. Okay, so guys, this is exactly what I was talking about at the warm-up. Under the square root, we've got a negative number, so that's going to be imaginary. These are going to be imaginary solutions. So what we need to do is we need to take our negative 243, and like we did when we first learned about the imaginary unit, we'll take that square root of negative 1 out, guys. That's I, and then we're going to simplify that 243. 243, I think, has a factor of... what would 243 have a factor of? Maybe 13? No. Guys, I'm just checking some numbers here. Honestly, off the top of my head, I'm not thinking of one. Let's try 6. No. 3. 3. Yeah. 81 times 3. You guys, then we know 81's 9 and 9. Okay. So this would be, what would this be? This would be x equals negative 3 plus or minus the square root of 9, guys. That is equal to 3 times the square root of 9 is equal to 3. Okay, so 3 times 3, 9. I, we got that. That's equal to I. So we got yeah, we get I, 3 times 3, 9i. We do have the square root of 3 left there, all over 18. Okay, this one is, this is really close to our solution. Guys, what we do need to recognize is the 3, 9, and 18, guys, this is a fraction. They all have a common factor of 3. So we need to reduce them all by a factor of 3. Reduce our fraction still. So our answer will be, well, negative 3 reduced by 3, that's negative 1, plus or minus 9 divided by 3, that's going to be 3i. Guys, notice we're not going to reduce the radical because the square root of 3 and the number 3, guys, those are certainly different. Okay, and then 18 reduced by 3 would be 6. So we just reduced all the real numbers, all the coefficients there by a factor of 3, that common factor. So this now is our answer. Okay, so this is reduced. Okay, so make sure you're reducing them. On your homework, 1 or 2 of them is going to reduce. This will be our only one in the notes that reduces, I do believe. I'll probably misspoke once we get to 11. I don't think this one will reduce, but let's take a look here. So, doing the same process, guys. X equals negative b. Well, so a is 11, b is negative 1, c is 6. So, negative b, that's going to be negative 1. Guys, again, anytime you're using parentheses to substitute, anytime you're substituting, use the parentheses, guys. So negative b plus or minus square root of b squared, so it's going to be negative 1 squared minus 4 times a is 11 times c is 6. So that's going to be another big number there. All over 2 times a, 2 times 11. So what's this all simplify to? X equals negative 1, that's positive 1. Plus or minus negative 1 squared is 1. Minus 4 times 11. 4 times 11 times 6. Minus 264. All over 22. Okay, so this is going to be equal to 1 plus or minus square root of negative 263 over 22. Guys, the 263 is not going to break down. It will break down. 263. We're trying to break that down again. We got negative 1, square root of negative 1, which is equal to I. And then the 263, if we break that down, I would start with a 3 and 88. Square root of 88, you get square root 4 and square root 22. 22 will break down to 11 and 2. Don't need to break it down, though. This ends up being square root of 4 is 2, so our solution, guys, I kind of did our work right in the middle of the problem, so I'm going to write that a little lower. X equals 1 plus or minus 2i, and then we got square root 3 times square root 22, which is square root 66, all over 22, guys. In this example, 1, 2, and 22, no common factors between all of them, so we can't reduce it further. Okay. All right. So that example did not reduce. Guys, this last example, only difference here, well, it's not equal to 0 off the bat, so you would need to, again, so on your homework you should be checking 8x squared minus 5x, we got negative 8 plus 9, that'll be plus 1, equals 0. Okay, so A is 8, B is negative 5, and C is 1. Okay, make sure they're in standard form, equal to 0. Okay, common mistake there. All right, from there, guys, I think you guys are probably confident solving using the quadratic formula. Okay, the examples we're doing on our homework, they'll all have imaginary solutions. All right, guys, a little word of encouragement. I know it's been tough with DLDs. It's certainly a lot different than class, at school. Do understand that. Guys, there haven't been a lot of questions and discussions. If you do have them, I encourage you to post them. If that's not something you're comfortable doing, send me a message on Canvas or my email. I'd be glad to get back to you there. But I think it is useful to use those discussions where peers might be able to respond. I can post a response that maybe a peer had the same question but didn't want to ask in that public forum. So, guys, if you've got a question on it, there's chances are someone else probably will. So, don't hesitate to use that. Or reach out if you're struggling in any way. We are going to end up having some type of assessment here on Chapter 4. Haven't finalized what that's going to look like, but do know that's coming. So kind of review. I'll give us some things to review probably tomorrow. So everyone have a wonderful afternoon, and we'll see you all tomorrow.